our team from Daugpilio University or NGO of was involved in the project LIFE Osmoderma. And one of the tasks for our team was to develop smart traps for smart pheromone traps for Osmoderma monitoring. I have together some traps. Yeah, you can free to take a look after this presentation, and yeah, I will briefly talk about the development process of smart traps, since I'm more familiar with the use of traps and their body construction. I may not be able to answer questions about the technical details of the trap, but if you are interested in this aspect, you can find published information in our article about this trap. Usually several methods have been used to study and monitor population of genus Osmoderma species, mainly based on searching or capturing the adults by adhere pitfall and pheromone traps, or visual survey and wood mold sampling, searching for the remains of adults, or larva fecal pellets in hollow trees. However, these methods are often used in combination to achieve greater sampling efficiency. Here you can see pitfall traps, pheromone traps, and different construction, and also wood mold sampling, where we can find also larvae and also some pellets and maybe parts of imago of Osmoderma individuals. If we are speaking about these methods, so there are a lot of cons of current monitoring methods, but we can talk about pheromone traps. Pheromone traps, first of all, do not show attraction of individuals to the microhabitats of or separate tree. The dispersion of individuals in different sources is mentioned from 100 meters to 2,300 kilometers, and according to our actual research, up to 4 kilometers. The hermit beetle's imago activity is highly dependent on environmental condition. Therefore, monitoring of these species with standard pheromone traps often has situations when the placed pheromone traps are empty for a long period, and in such case, time as well as financial resources are unnecessary spent for surviving. Therefore, the method is time-consuming, requires a lot of resources because the traps must be checked regularly. It's also difficult to hit exactly at the moment when the species is active, because the activity of species is different in different areas. According to the existing methodology, the assessment of the species must be done with limited resources. You can go to the territory only a few times in the season, where is lack of resources to ensure long-term monitoring. On the other hand, in the appropriate weather conditions, beetles fall in trap regularly, and there is a risk what if the trap is left unattended for a long time, the lethality of specimens is high. So I want to show you situation with records of occurrence of Osmoderma in Latvia. Here you can see 4 points, and you can see how improved our knowledge of Osmoderma in Latvia. I think one of the reasons how this knowledge was improved is pheromone traps usage. So this situation now and about 40 years ago is quite different. We started to use pheromone traps about 15 years ago when we carried out another LIFE project, Eremita Meadows. Here you see some historical photos, and this trap I saw also in Gedrius' presentation with our first model. Here I see one part of this trap, but all these traps are not completely ready to use because we have a lot of parts of this trap, because we use these parts for another generation traps. So what can be used is used in new trap systems. Of course, this idea of pheromone traps, of smart traps, it's not new. You can see here a lot of traps, and in accordance with the ecological characteristics of target species and monitoring needs, various traps have been developed for remote monitoring of mainly for insect pests. Typically, an automatic trap equipped with camera involves 2 modules, the hardware and the software. The hardware typically composed of trap structure containing the bite and retaining the trapped insects, an electronic box including the camera, a data transmission modem, a battery, and eventually an external power supply, such as solar panel. Software is composed of online repository in which the captured data pictures are stored. In some cases, also optional image analysis algorithms to automatically identify species and count the captures were used. Previous we start to develop our traps, we have such information, and we start to create our traps. Here you can see main benefits of this smart traps. Main idea of this, we have economy of human resources, economy of fuel, economy of time, and also we have additional data. Temperature and humidity data. But in this case, I partly agree with this information, because if we are working in a wider territory, some of traps always will be successful with trapped beetles, so we need to go to the territory anyway. I think what smart traps are necessary in some situation. For example, now our traps are in the field, and we waiting for starting of the season of flying beetles. So if we have these smart traps, all smart traps, we can monitor situation and go to the field only when beetles starting to fly. And second reason why we can use these traps, and this is small territories where the activity period of beetles are more short due to small populations. So it's more easy. If we want only detect the presence of species in a local place. For study process, of course, very interesting data is with humidity and temperature data that shows us ecology of the species, phenology of the species, and activity periods of the species at all. What main requirements for hermit beetle smart traps? Of course, traps must be able to attract beetles. The next one, high survival rate of captured individuals, easy to use, operate autonomously, and traps must ensure regular data transmission to the server. And of course, reasonable trap costs. When about our development process, from the first edition of this trap, I found only this bucket, historical object. Maybe somebody wants to buy it for some money. You can. Yeah, and main things about these traps working in radio frequency, so have solar panel and lead acid battery, and industrial controller. I don't know what's that controller, but the time how long traps can work, 3 days. Of course, it's not enough. This solar panel not working like we think, because it was shaded by canopy of tree, and so in this case it's not enough electricity from panel to charge this. Okay, I understand. Yeah, to charge this trap. So weight 6 kilos. I don't know how many weight this battery, but a lot. So the next trap worked on GSM network, have onboard computer. I think it's Raspberry, but have full-time record video camera. In this case, we have light interruption detector. If here is you can see another solution. So we think what this sensor was not working. So if we have this full-time record video camera, in this case, I think electricity consumption was very big. So it's also not a good thing for these traps. So weight 11 kilos. This is what prototype. how I remember, our colleagues from Lithuania was not happy to take these traps and bring somewhere in the field. So there is a lot of logistic problem to take it from the one point to another point. So and here you can see 21 days, and here you can see the final prototype of traps. How I understand, some traps are still working here in Lithuania. Unfortunately, we have no any working traps in Latvia. I found this one, how it looks, and of course here is a lot of wires. So that is one of the problems of this trap. You can see here how many wires, and due to this amount of wires, connection was low, and problems may be possible. But we use periodical data transfer. I think it can be from some minutes to... Oh, okay. But we use lithium batteries. If we compare this one with this one, we can see the difference. And 30-40 days. Periodical recorded photo camera, onboard computer, and this is from our data server. We can receive such information from each trap's temperature, humidity, trap number, and also photo. Here you can see also beetle specimen. And at all, we have raised a lot of problems with traps, a lot of works, and yeah, it's very strange work. And here you can see the last model of our traps. You can see what were less wires. This microchip was designed by our specialist and ordered in China. So we have only one lithium battery. Here was 2 batteries, you can see, and this trap can work for 5 months. And can here, this is a picture from our paper about these traps. This is this sensor. When beetle falling down, this light signal interrupted, and trap sent signal to our data server. Here you can see the process. All traps bodies was printed by 3D printer. This is what microchips from China. And yeah, of course, monitoring is very necessary, and given the increasing trends in anthropogenic pressures on nature ecosystems, the need for objective monitoring methods for rare and protected species will only increase. Here is what about our research. That's all, I think. Yeah, thank you.
Na, čia tokia įdomi tema. Iš tikrųjų, tos išmaniosios gaudyklės, you expect that we still have some working ones, but Alvydas is struggling with them. They don't really send pictures, but your new improved version, I believe it is better.
Yeah. We are still working with this new version of traps, and we are thinking how to do and now we are using these traps without modem, because we are checking we have a lot of these simple traps, and we need to go to the field every week anyway, and so we don't need this data transmission in any case. So now we use traps without data transmitter, but we check this data using micro SD card. Here is the slots with micro SD card and slots, and we take the data every time when we visit these traps. So, but these traps, of course, more simple and working better than all the traps. One difference between traps we saw what used in Lithuania. This is this bridge from the tree to the traps, and we hope that beetle can go more easy by this bridge to the from the lino to the traps. So we have also this modification, and we think what using this net, beetle can go insert more easy, yeah, and we can put this trap everywhere, not only near the tree.